Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
I've just been working on the Kotlin book this week.
I've been working on a lot of Kotlin this week too.
Yeah, how's that been for you?
It's actually been really delightful.
Yeah.
I haven't done a lot of unit testing in Kotlin yet, and so I started exploring some unit testing stuff. And I asked on the Kotlin Ling chat, I'm like, what should I use for unit testing? And some people said Kotlin test with JUnit 5, and
that's what we have in the book.
Oh, nice!
Just because we figured JUnit 5 is so ubiquitous and popular that might as well start from there. But then the Kotlin test is a facade.
Yeah.
So you could use anything with that.
So I ended up using Cotest.
Right.
How and it's been great. It actually, I think that they have been inspired by a lot of Scala test and Scala specs, two different testing frameworks in Scala. And so it actually feels really similar to Scala, the Scala stuff that I've done. And this project that I was working on, I actually took some Scala code and migrated it to Kotlin code. And migrating the tests was so trivial because the syntax was so similar between the two, between Cotest and Scala test, I think is what they made it like. So it was enjoyable and easy to migrate the Scala code over. I'm trying to think if there was any places. There was a couple of places where I was using kind of monadic stuff in the Scala code, and that obviously was a little more challenging. In the Kotlin code, there
are some at least one or two monad libraries.
Yeah, Kotlin, I could have used Arrow or something.
Yeah, Arrow, right.
And I actually am using the result class in Kotlin, which when I first tried to use it, it was like, oh, you can't return a result. And then I Googled why can't I return a result? And it's like, oh, because this is like an experimental feature. And so then you have to enable a compile flag to enable the result object. But the result object is monadic. So because a lot of my data types are based on the result type, it's actually I am using monad, so it's actually been great and super easy to convert. I was on the Scala code, I was using a try, which is very similar to the result object, something that can succeed or fail.
Capital T try.
Yeah, capital T try. Yeah. Yeah, and so overall it was pretty darn trivial to
so is result we didn't cover that in the book. Is that part of Kotlin?
It is. It's actually in the Kotlin standard library, but it's marked do not use this. No, not even experimental. It's pre-experimental or something. I don't know why. I think it kind of opens the can of worms on the topic that we've talked about, error handling in Kotlin. And I think as soon as they kind of say oh, here's this result thing, maybe you should use it, then all of a sudden it's screw nulls and exceptions. This is so much better. And I think that I think probably for Java compatibility, they've really kind of tried to not go that direction.
They've been hesitant,
But man, the result class return type is just so much cleaner. Well, and especially because I need to chain stuff, and that's what we've talked about. The value of monads is the chainability, and so.
Isn't that? I'm a little I haven't been thinking about this that long, because I think about one of the parts of functional programming is composition, and chaining feels like composition to me, but I know it's not. A calls B calls C inside of parentheses.
Sequential composition, I think.
Yeah, I mean, it feels the same to me, and it seems like it has the same issues, which, how do you handle errors in between? What you'd like to do is just call these things and not have to think about errors within each one. And so it seems very similar to me, but I don't know. Is chaining and composability basically the same thing?
They're related for sure.
Yeah.
I think we talked about it on a previous podcast when we talked about monads, but the problem with chaining things that have kind of this wrapper type around them is that you don't want your your method parameters to always have to take that object, that kind of outer wrapper in the parameter type. You want it to just take the value, because really all you want to do is operate on the value. And if there isn't a value in the case of something like a try, then you don't even want to have that be recognized in your type signature for valid inputs into the function. And so yeah, it's composing, but it's composing in a way where you've got this wrapper that is giving some information about how to get the value out in some cases and pass that to the next piece of the chain. So yeah, I think it is related to, it's a form of composition.
So in any event, you pulled the trigger and said, I'm using the result type, and it was a nice experience.
Oh, it was great. Yeah. It was, yeah. I mean, and I could have written my own. There's other libraries out there for Kotlin that have a result type, but I just used the one that's in the standard library with the compiler flag, and it was great.
Because why wouldn't you?
Yeah.
They've probably thought about things you haven't. So
yeah. And like sprinkling in some extension methods and the one thing that I ran into that maybe I could have come up with a nicer way to do it, but in Scala there's a nice way where with method parameters, if you have, let's say you have two parameters that take functions, in Scala there's a pretty nice way to like make calling that look good. And it kind of is similar to the way that Kotlin does it with a single function parameter at the end.
At the end, sure.
Yep. But what I ran into is I have a method that needs to take two function parameters. And so in that case, I kind of expected like, oh, I'll be able to chain this by just doing like braces and then braces again, not in the parentheses, outside of the parentheses. And of course that didn't work because it only works on one functor parameter.
In Kotlin.
In Kotlin, yeah.
But Scala, it works on more than one?
You can make it work in Scala because you can do multiple parameter lists, which tripped me up for a while when I was just getting used to Kotlin or getting used to Scala. But you can have parenthesis parameter list and then parenthesis another parameter list, parenthesis another parameter list.
Oh, in parentheses.
Yeah.
Yes.
And so that allows you,
yes,
it's like the function currying stuff allows you to then have the syntax where if you have two function parameters and two different parameter lists, then you can do, your main parameters in parentheses and then open brace, close brace, open brace, close brace for those two functor parameters. So,
and that's Scala. That's not just Scala 3.
That's Scala.
So,
for as long as I've known it.
That term functor has, because I thought long ago I thought I knew what a functor was, and I don't even remember what I thought it was. But then
I probably don't even know what a functor is.
Oh, okay. Well, maybe I won't ask you.
So my understanding of it is that if you have a function that takes a function as a parameter and or returns a function as a parameter, then that's a functor. So I think I was actually probably misusing it earlier where I said that the parameter was the functor. I think actually the thing that takes a function as a parameter is technically the functor. But
okay, because I have a friend who has more of a background in math, and I think he made me, he said something about, oh no, a functor is actually got, math constraints on it that I didn't really understand. And so I was using it wrong. So you might also be using it wrong. Just a heads up.
I use all terminology wrong.
Oh, good.
Yeah.
So yes, this authoritative podcast, at least we're admitting that we're doing these things wrong.
Yeah. I like to just use these things, and sometimes I remember the terminology for them. And monads I definitely do, because I've spent a lot of time trying to explain monads, and so I feel like
those are the things that are like burritos, right?
Exactly.
Okay.
Just like burritos.
Okay. Yeah. Well, that clears it right up for me.
Yeah, exactly.
Yeah.
You got it.
It's a burrito.
You got it. So this project, CoTest was really nice. And then I'm using Gradle for the build, And Gradle has a really nice way to tell it what tests to run when you run your tests. And unfortunately, you can only do it down to like the class level, but at least you can say like, okay, only run the test for this class. And it's just a command line parameter. And then Gradle has the continuous mode as well. And so in my case, I'm doing Gradle W minus T test, and then dash dash tests, and then my class name that I want to run. And then as soon as I save my changes, it's automatically running the test just for that class file. So it's really nice for kind of rapid testing. It's not quite as nice as what I do with Scala and SBT. SBT has a way to kind of regex the name of your test, essentially the name of your actual like test case, and not just the class. You can also do it in the class or whatever, but has a much more granular way to specify which test you want to run. And then SBT has some other test like test quick, I think it's called, like I think tries to detect what is changed and only rerun the affected test or something like that. So there's some nice little tricks that SBT has done. But anyways, what I found with Gradle and CoTest is just nice, very iterative development experience. Oh, and I want to say this cool thing about CoTest, which was I had this I have this one place in my code where before I was just like running this command and then thread.sleep for like 2 minutes or something like that, and then do my check, do my assertion. And that's obviously horrible. And I didn't have time
because your tests would take a long time.
Yeah, exactly. No matter, how long it actually took to do the thing. And CoTest has built into it, and I'm sure that many other test frameworks have this too, but it has this really nice syntax where you say eventually, and then you give it how long you want to allow it to try for. So I say like eventually 2 minutes is how long I expect it to complete in at the most, comma, how often you want to check. And then you provide a function that it's going to run on that time interval and check the output with your assertion
to see if it's done. So that way your test can run a lot faster if it finishes sooner than 2 minutes.
That's right. Yeah. Yeah. It was just super nice syntax for being able to have that kind of test that needs to periodically check a condition.
So let me ask, since you've had this experience going from Scala to Kotlin, and since we're starting this project where we have a lot of Kotlin code, what do you have any perception of what kinds of issues we might run into converting Kotlin to Scala? How hard that might be?
For our books.
For the book.
Yeah. I think there's going to be a lot that is just pretty easily directly portable over. I think that in some ways Scala just has more than Kotlin, more features. There are some places where there are different paradigms, like the usage of monads and the standard library and for error handling, that kind of thing. And the usage of like option and stuff. So I think there will be a little bit of that, but that stuff is pretty easy to convert over. It's like in my code, I have option string. Well, we just turn that to string ? In Kotlin, and like boom. Except unless you want to do like monadic operations on the option, which I was doing in a few places. But yeah, I think generally it's gonna be pretty straightforward to get what's in Kotlin moved over. I think where it's gonna get tricky is, okay, now we need to add a bunch of stuff for all the other features that Scala has that Kotlin doesn't have. So
sure, especially Scala 3.
But yeah, I mean the syntax, like it's really easy for me to go back and forth between Kotlin and Scala. Yeah, much easier than any other languages. I kind of work in at the same time. Like JavaScript to anything is just hard.
I don't even know, because I've written JavaScript in the past, but I know that it's changed so much and improved as far as I understand, that I don't know that I would recognize it at this point.
Well, and it's gotten really confusing in terms of like, what should you do for the async? Because at this point, there's like 100 different ways to do async stuff. And there's probably like the newest, best way to do it. But can you only do that in Node? Can you do it in the browser? Can you do it in some browsers?
And what about next week?
That's right. And next week. Well, and what I found is that as I search for information about like a particular way to do async in JavaScript, I find like the 10 ways to do it, and then I just get lost. I'm like, are we talking about promises here? Which promises are we talking about? Which promise library? Oh, we're talking about some Node.js like feature that got deprecated and is no longer the way to do async. Or I ran into a place recently with Node where I was doing async, but I needed top level async. And so I need like a function, at the top level that was async, and the version of Node I was on didn't support that. But then there was some new version of Node that I could use, and maybe a compile flag.
So it's JavaScript.
Just a disaster of options.
Did they build in an async and await keyword?
They did. Yeah.
But is that the accepted way to do things, or people?
I think that that's the right way to do it now.
Okay. Well, right. Because I know in Python, that's what everyone is moving to.
Yeah.
And then it's like transparent and fundamental for everybody.
Yeah. Yeah. So I think that generally the JavaScript community is converging onto async await or whatever.
The built-in ones.
Yeah, the built-in ones.
Yeah.
But then you'll use a library that hasn't yet converted over, and then you have to like figure out how to interop, and it just is a disaster.
Yeah. So well, that's fun.
Yeah.
Yeah. So that's an example of a language that yeah.
So I've done some Kotlin JS stuff, and it was actually a pretty delightful experience, and I definitely will reach for that where I can versus actual JavaScript.
Right. And I know that I don't know what the situation is with what's the I've lost the word, the assembly language equivalent. WASM. Yeah. So I know that Kotlin either generates WASM or is on.
I don't think it generates WASM yet, but I think that they are moving in that direction.
Yes, and that's part of the native thing. So because if you're using if you're you don't have a JVM or anything, you've got you're doing it there. But I can imagine that, I don't know, my imagination takes me to a point where we can take our whatever language is the most effective to solve this problem, put it in WASM, have a little layer of JavaScript on top of it, or that's calling these things, and then mostly not using JavaScript.
Yeah.
That's what I imagine.
Yeah. That's what I hope for, is a world where I mostly don't have to use JavaScript.
Yeah.
Then hopefully I can apply CSS someday to that statement too, because CSS is just.
I know. It's like it's another one of those things that really needed to be a language. It needed to be designed by language designers, and not I think
it is Turing complete now.
Is it?
I think so.
Okay, I haven't been
through like horrible hacks.
I haven't been keeping up, but I just remember when I first started learning it, and I criticized that.
Oh, just the language. Well, I mean, like JavaScript, it's just like thrown together, piece by piece, with no real like actual design.
It was the designers were learning about new language features as they were adding them, and or PHP is another example. It's they started by solving this particular problem. Personal homepage. Did you know that's what PHP stands for?
I think I'd forgotten that.
Yeah, that's personal homepage. It's like they were just trying to solve that problem. And then people go, oh, we can use this for other things. And then so they slowly became language designers and learned these features and cobbled them in. And then I'm sure in hindsight go, oh my gosh, we didn't do that right. And, and that's kind of what happened.
It's like if I tried to design a language, it just would not go well.
I think,
and I have, I've like designed like my JSON DSLs, and
Mm-hmm.
yeah, and it just, it all seems easy at first, and then you realize, oh, I didn't think about that.
The easy parts are easy.
The easy parts
Yeah.
are easy.
Yeah. Just put in generics.
Yeah.
Add generics.
Just,
Yeah.
yeah, throw some generics in
Yeah.
there.
Because I mean, I don't know if you know or remember the story, because initially generics were brought up. It was actually the guy who lives in Aspen, who was one of the founders of Sun.
Bill Joy or something.
Bill Joy.
Yeah.
Yeah. Because when Gosling was talking to him about this, Bill Joy said, you should really think about putting generics in now before, the language gets used. And
yeah,
I guess Gosling was like, yeah, it's too hard.
Yeah.
We'll just throw this in, and
yeah,
we don't have the time.
Yeah.
We're in a hurry.
Yeah.
So,
well, and is Java one of the first languages that really had a generic type system, or was
no, I mean C++ had templates.
Okay.
And were they based on something else? Yeah, I think there were maybe more experimental features before that. But
what is interesting is how kind of Java style generics have kind of become, in large part, the standard for how we do generic programming now.
It is. I mean,
at least syntactically, I think that that the actual kind of underlying system of it has changed in different languages, but
it has. I mean, and I go back and forth. I mean, my first experience with generics was with C++. And so the idea that you say, I'm making a generic for this type, and it goes, all right, I'll lay down the code for that type. And inside that code, you can treat that type like that type.
Yeah.
You know what it is. And that was my initial experience with it. And so when Java came along and said, we're not going to let you do that, we're going to erase the type and everything, I was just like shocked and horrified. And over time, I've come around to going, well, yeah, I mean, it's nice to do what you can in C++. That's very powerful. But what's the basic reason that we use generics? It's primarily containerish things. And what erasure does is it goes, inside the container, you can't know what the thing is.
Yeah.
I mean, Kotlin has inlines and reified together, allows you, but even then it's just a little bit more information. It's not like C++. But in the end, what it is, it's like, when we give you the type back, we'll give you the exact type back.
Yeah.
That's where you see it. And you go, most of the time, that's okay. That's what we need. Yeah, there are some times when it would be nice to have this C++ functionality, but not as much as I initially imagined that it was necessary. So
I watched this great talk. I don't know if it was Philip Wadler who did it, but I can't even remember the terminology for it. But there was parametricity or something like that. But it was talking about how when you should make every function as generic as possible.
Mm-hmm.
And so the example that was used was, if I give you if I tell you, okay, here's a function that takes a generic type T and returns a generic type T, you can infer what that function does as a pure function. So if all that you have is a generic type T, you have no type information about that T, and the function returns a T, the only thing that function can possibly do is just return the T. Because there is no other, you have no other operations that you have no other information.
No information telling you what is possible with that type. Yeah.
Yeah. And so then this talk kind of walked up from there. Okay, if I tell you that I have a function that takes a list of T and returns a list of T, again, there's like three possible operations that can actually fit in that function. You could do a filter is one. You could just return the original list is another.
Well, you could map something onto it. if you had
You
an
can't-
extra argument.
If you had an extra, yeah. So
Okay,
this
you're
is the thing.
saying no extra argument.
No extra argument.
Okay.
Yeah. So you could do a map, but your T is going to still have to be a T. So like actually map on a list of T to a list of T, like, is actually useless in that scenario. If your type signature was list of T to list of R,
right,
some other generic, then you would have to provide a map function, some way to get from a T to an R, and that would have to be another parameter. But the whole point of this was that that the more generic you make your functions, the more people can infer what is actually happening in your function, or the more limited of capabilities you have in your function, which is good for conveying to the function caller what's actually happening. And so I thought it was an interesting way to look at it. I think it's called parametricity or something like that.
mm-hmm.
But I found that interesting, and I've tried to do that as much as I can. Like, okay, if I can pass a generic here instead of a concrete type, then I should.
Yeah, I could see that.
Because there's cases where, let's say you do want to have some operation, and in your use case, you're taking a list of foo and returning a list of bar or something like that. But if instead you can genericize that function to be a generic list T to list R, then that actually, like, that constriction of what's possible in that case is actually a good thing.
Mm-hmm. Sure. Yeah. I know, generics are kind of an endless source of mental contortions. Because when you start thinking about them, I feel like what we did in the Kotlin book, in Atomic Kotlin, I feel like we really got some of the essence down, like even covariance and contravariance. As much as I was fighting to keep those terms out, and Svetlana kept wanting to put them back in, and finally we got to this point where it was like, okay, this isn't too long, and I think it actually does help internalize what the terms mean and how it works. I think we really hit it. I'm quite pleased with the results of the book. But so we were also going to talk maybe a little bit about macros, which is another kind of
well, and this kind of stems from a tweet that I made this week that got some people fired up. So it's actually two parts. I said, one of the best things about GraalVM is how it's going to force us all to not use reflection.
Mm-hmm.
And then I had to clarify.
Hashtag reflection is bad.
Reflection is the devil, or as Bill corrected me today, it's one of the devils. But I said, to clarify, GraalVM native image, which is important, we'll talk about this in a second, supports reflection, but it needs to be explicit. Some JVM libs and frameworks are moving away from reflection, and I'm happy about this because I would rather do the most possible validation at compile time, and I've had too much pain debugging reflection.
Okay.
So I was working on a project where it was a Kotlin project, and I was trying to get it running in GraalVM native image. And it's important for me to clarify the difference between GraalVM and GraalVM native image, and that was one of the things that I was clarifying, was that GraalVM native image is what we've talked about a few times, where it will take a JVM based application and ahead of time compile it into a native image.
So there can't be any reflection because it's all ahead of time compiled.
There can and can't be.
Okay.
GraalVM native image just needs to know about the reflection. So you have to explicitly tell it the classes that get reflected on, and the methods that are exposed, and the information that is accessed through
that
reflection.
with annotations or something.
There's a few different ways to do it, but the most common way is a JSON config file, where you just put in the class names and then put in, do you want all properties to be accessible, etc. So there is some ways to generate that configuration, which makes it nice, where in a lot of cases you don't have to come up with it by hand, but it can be kind of painful. And I experienced a lot of that pain this week when I was trying to get this Kotlin GraalVM native image application, native compiled into a native image, specifically around JSON serialization, because JSON serialization is one of the places where on the JVM we typically use a lot of reflection to like generate serializers and deserializers, like do that all through reflection. And coming from the world of Scala, we don't use reflection for that. We actually use there's a couple different ways we'll talk about in a minute for how to do that. But the whole point of my tweet that I was trying to highlight was that because ahead of time compilation needs to have this explicit reflection information, a number of frameworks and libraries are moving away from reflection. And I consider that to be a really good thing, because reflection, to me, it's just like this anti-pattern for, we're using a statically typed language, but then we're like doing a bunch of our stuff at runtime instead of being validated by the compiler.
You're cheating your way out of it.
Yeah, but I totally understand like why it has been necessary to use reflection, because we didn't really have the other tools available to us to not use reflection. And so we just had to reach for we didn't use reflection because we wanted to. It was the only way to do what we needed. And so dependency injection, JSON serialization, like all that kind of stuff, just reached for reflection because it was the only possible way. So one point I want to clarify about why I had to get specific around GraalVM native image is that GraalVM is also just a JVM. So you can run your application in GraalVM in a JVM, and in that case, reflection works just like it does in any other JVM.
So it's kind of like what Docker is to Linux, GraalVM is to the JVM.
Yeah, GraalVM is just a JVM, but GraalVM also has this tool to ahead of time compile the application into a native image.
Right. And so what does it do with reflection? I can only vaguely imagine some kind of mechanism that is able to generate a bunch of code that replaces what the JVM does for you dynamically.
Yeah. Yeah, exactly. It's got to do a lookup, right? If you're doing reflection, it's doing a lookup. And the challenge with reflection for ahead of time compiled things is that it doesn't know how to follow that code path, right? It is at the point where you're using reflection to do something, you are you're giving it a path that it can't follow ahead of time in an ahead of time compilation, because it's not a compile time construct. Reflection is a runtime construct. And so by giving GraalVM native image the JSON config file for the reflection information, now you've told it all the places where it needs to know that there's going to be a code execution path through.
So it's almost like it's installing dynamic binding for those things. It's almost like making up its own virtual functions.
Yeah. I don't know how it's all implemented under the covers, but yeah, I think conceptually it's something along those lines. Okay. So I'm a huge fan of doing as much at compile time as possible, and this includes like the wiring of dependencies for dependency injection. This includes like creating JSON serializers and deserializers, kind of all the stuff that we typically have done in reflection. Like we now have tools available to us to do this at compile time. So as an example, Micronaut is a framework that uses annotations, just like Spring and Quarkus and other frameworks, but they actually implement those annotations at compile time. So they're not doing reflection. So Micronaut typically, as long as you're not calling into libraries and stuff that do reflection, works really well with GraalVM, because it's not runtime reflection, it's compile time annotation processing. And to do this, they actually use the Kotlin annotation compiler, capped. I don't know if you've gotten into cap stuff in your I think it was created for something with Android, but Micronaut was able to use it. And I think that I'm speaking accurately about how they actually do their annotation processing at compile time, but I could be wrong about some of this. But I know that they do their annotation processing at compile time, so they actually can at compile time create the dependency graph and validate the dependency graph, which is really nice. So that's one way to get around using reflection and move it into the compile phase, is to use annotation compiler of some sort.
And so is there a lot of performance impact by doing this?
There is, because reflection is actually pretty expensive in the JVM to do. And so by doing it all at compile time, you really have much more optimized code paths. And so one of the things that Micronaut touts is their startup time is really fast. And Spring Boot has done a lot of optimizations, and I don't know how they've done the optimizations, but they've done a lot of optimizations. So their startup time has actually gotten really good too. But yeah, Micronaut starts up super fast because it's not having to do that runtime dependency graph figuring. And then for me, the biggest benefit is that like things are not dynamic at runtime. It's like I get static capabilities, not just for my classes and code, but also for my annotation based wiring. So that's one way to get around to not use reflection. In the Scala world, we typically use macros as the way to not use reflection. So there's a way to hook into the compiler, and a library can add its own macros so that instead of doing things at runtime through reflection, you do things at compile time. So you actually a macro will generate a AST that gets injected into the program AST.
Yeah. So as a little bit of a going back and historically, like if you're coming from C or C++, you hear the term macro and you think it's just some basic compile time substitution using sed or something, which is probably how they initially implemented it.
Yeah.
And then my experience was that I came across Lisp, and people would say, oh yeah, there's Lisp, and then there's Lisp macros, and that's like incomprehensible. And, obviously it's not totally incomprehensible, but it was because it was a different paradigm when you were trying to use Lisp macros than you were programming in Lisp. And then Scala has had macros, right?
Yeah.
But historically they've been like a different, you have to, it's not.
I think at the low level you're writing the AST.
Right.
But what I never went down to the lowest level. What I used was something called quasi quotes, I think it is. And quasi quotes lets you embed essentially Scala syntax into the code, and then the quasi quotes at compile time compiles that block of Scala and then turns it into the AST or whatever that's then needed to be injected into the compiler.
Yeah. But originally Scala 2's macros were in something that wasn't Scala. And now in Scala 3.
So you could essentially do it in Scala with the quasi quotes.
With quasi quotes, but that was a third party library.
Yeah.
Right? Okay. Yeah. So, but the way they designed Scala 2 was, it's like, oh yeah, there's this other thing off to the side, which is macros, and that's different.
Yeah.
And now in Scala 3, you write macros using Scala 3.
Yeah, so in Scala 3, one of the big things that they have been trying hard to do with Scala 3 is to make the type system sound. And
sound like what?
Sound like cheering. I've tried to explain what type system soundness actually means, and I don't have a good way to explain that, but
I mean, it sounds mathematical.
It is. Yeah.
Okay. Yeah. So that guy who got his PhD in type systems would be able to understand it. Maybe not explain it, but understand it. Yeah. I mean, so it's presumably it's a consistency.
Consistency between compile and runtime is, I think, the biggest part of it. Is that like once you have validated the whole type system, every type used in an application at compile time, you should never have a case at runtime that you get a type that violates what you validated at compile time. So I think that's, I may be way off, but something along those lines is what type system soundness is about. So macros are a gigantic hole in type system soundness, because with your macros, you can do crazy stuff that totally violates the ability for a type system to be sound.
Mm-hmm.
So it's kind of cool that you can kind of do whatever you want, but it also is one of the goals of Scala 3 being type system soundness.
Including macros.
They spent many PhDs trying to figure out how to redo macros into something that could maintain the type system soundness.
I like the way you put that. Spent many PhDs. It sounds like, oh, that
those poor PhDs,
or the scene in that. What was it? The ones where the Spartans were, and it's like somebody comes along and they don't fit the mold and they just kick them into the pit.
Yep.
So that's.
I think there are some PhDs in the pit
whose lives have been ruined trying
to replace macros with something that would not break the type system.
Uh-huh.
So Scala 3 did come up with a couple of ways to do this, and it's all under the banner of metaprogramming.
Mm-hmm.
So I don't know a whole lot about this, but you're right that one of the ways is that you can use Scala to write to metaprogram in a Scala program, that then the compiler can then use that metaprogramming to do things.
And so basically what's happening is the Scala compiler takes your Scala code, it parses it, it builds the abstract syntax tree, and then at that point, your macro can come in. And in Scala 3, using Scala syntax, you can manipulate that abstract syntax tree to do amazing things.
Yes.
Okay. Which you can't do with regular Scala outside of the macro.
Yeah.
Right.
Yeah.
So for example, would this be a solution to, like in the book that we're talking about, we would like to be able to have a print statement, and we'd like to be able to hijack that so that it will capture the output of the print statement in something that we can later compare to see what we're expecting. Would that be a macro application?
Yeah, I think that we could do that through macros.
Okay.
Be interesting to try it and see.
Mm-hmm.
So that
might be our one example of macros in the whole book.
Yeah.
If it's not too complicated.
Yeah. I have done very little metaprogramming in my life, just because usually it's like, okay, the JSON library did the metaprogramming for me, so I don't have to. And so today, a lot of the Scala JSON libraries will have a macro mode that you can use if you want, that will use a macro to generate the serializers and deserializers for a case class. And it's nice and convenient. And so one of the use cases that they had to cover with their new metaprogramming stuff in Scala 3 was allowing you to solve for that use case. And so so there's another part of metaprogramming which I really don't know much about, but I'm fascinated by, is called GADTs. And I think that's general algebraic data types or something like that.
Are you sure it's not Google algebraic data types? But let's say it's generalized algebraic data types or something like that.
We actually in the Google algebraic data types, we added a subtraction data type.
Uh-huh.
So
he's kidding, right?
I'm kidding.
Yeah. Don't go looking that up.
Right. It's, why do we only have product and sum? We should have more than product and sum. Why not division, subtraction,
well, we just
factorial.
Figured out that...
why not a factorial, like, algebraic data type?
Is there we figured out that the product was not generally usable, so probably does other things are even less generally usable.
That's right. Okay, so GADTs are a metaprogramming technique that allows you to generate generate serializers and deserializers is a common use case for them.
Mm-hmm.
And that's about all I know.
Oh, that's it. Boom. Full stop. That's the limit of your knowledge.
But I know that Miles Sabin has done a lot of work to get Scala 3 to support GADTs and better metaprogramming techniques. And so I think there's, when we look at, okay, the past is using reflection for JSON serialization and deserialization. The kind of like where we are today is like macros and type classes to do that. And what the future looks like for languages for doing this sort of thing, metaprogramming thing, is GADTs. So that's my understanding of past, present, and future. And I think Scala 3 brings the GADT stuff so that we have yet a better way to do that type of metaprogramming.
It seems like
That's compile time and preserves type soundness.
Well, because it seems like macros are something that I'm just hearkening back to when I was on the C++ standards committee, and one of the things that Bjarne Strustrup was saying at the time was that he was making a distinction between library creators and library consumers, and saying that for the library, we want to move the complexity onto the library creators, so that the experience of the consumer is much better. And, for example, I think Python has achieved that amazingly well. And it seems like macros are almost another level of that. They're saying, yeah, we want, it's a trapdoor that allows you to get into things that you simply can't do or are just heinous to do in regular code. But the number of people who are going to do that, or maybe, that's where the complexity has been moved.
Yeah.
But at least with Scala 3, they haven't created a whole different language and paradigm for creating macros. At least, Scala, and you can still use it for macros. So it's a little bit more accessible, and maybe that'll be the right balance for this kind of thing.
Yeah. 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 I think it'll be interesting to see, like, I know that the PhDs did a lot of work to see what use cases are not covered by the Scala 3, the new Scala 3 metaprogramming things. And I think what I've heard them say, like Martin say, is that almost all of the common use cases that people were using macros for pre-Scala 3 are now covered through the metaprogramming stuff in Scala 3. So I think it'll be interesting to see, like, does that
Wait, are you distinguishing between macros and metaprogramming? You said...
Yeah, well, kind of. So in Scala 3, I think that they're not really supporting macros. I think that they're actually like dropping technically macros.
Okay, I'm not understanding something.
They have a whole new system of metaprogramming that is essentially macros, but doesn't macros can do anything they want to the AST in the compiler. But because that breaks type system soundness, they now have a whole new model for how you do metaprogramming in Scala 3. New syntax, new keywords, kind of stuff that the compiler looks at and says, okay, this is some Scala code that I'm going to handle in this way to metaprogram the AST.
But it's still Scala code.
Still Scala code, and not giving you direct access to manipulating the full AST like you could do pre-Scala 3.
Okay, so it's got limitations, but it's one of those limitation benefit trade-offs.
Yeah, exactly.
Yeah. Okay. All right.
Yeah. So I think that is why in Scala 3 they don't call it macros. They call it metaprogramming.
Okay. Well, that's very valuable to know. Okay. Yeah. That's really...
Because I think they actually technically are dropping macro support in Scala 3.
That's one of the breaking changes. They're saying if you want to do this, you can do it using metaprogramming, and that's the only acceptable way.
Yeah. Yeah.
Because then it's part of the consistent type system.
Yep.
Mm-hmm.
Yeah.
Okay. That sounds like that'll be very interesting to see. At least it feels more accessible to me.
Yeah.
Because I've never waded into full-on macros and tried to figure out.
And when I did the talk on Scala 3 with Josh Surratt, he did the part of the talk on metaprogramming, and I like kind of understood some of it, but
mm.
but a lot of it is just
But
over
you
my
were
head.
looking at your phone mostly.
Yeah, it did while we were presenting. Yeah, no, I mean Josh is brilliant, and I don't understand 90% of what he says, but the metaprogramming stuff was
Mm-hmm.
definitely over my head, and I think maybe part of it is just like I don't often have a need to metaprogram. Like I was saying, like usually the libraries that I'm using have done that hard work for me, and so
Okay, but I'm really, when you put out something like that to me, then it lights a little fire. Like for example, if we do live in a simulated reality, my interest is, well, the only interesting thing about that is, can you hack it?
can you hack
And
it?
so when you say, oh, here's this language and now there's metaprogramming, and I go, that sounds really, I wonder what you could do with that.
Yeah.
So I'm
Well, it'll be
intrigued.
fun to
Explore it.
explore it for
Yeah,
the Scala 3 book. So
exactly. Yeah. And I'm not sure that I would be up for doing that on my own, but if the three of us can go thrash around with it, we might get
yeah,
somewhere.
I guess it's interesting that there are language features that are targeted at library authors, and there's language features that are targeted at library consumers,
Mm-hmm.
and it's different. We have different needs, and so I don't think I've ever published a Scala library. I'm trying to think if that's true, but um, if I have, I don't remember it. So I have different needs than people who are primarily writing libraries. Um, so one of the places where I've seen some really interesting uses of Scala 3's metaprogramming is there's this library that I use called Quill, and Quill allows you to write Scala code to that then gets turned into SQL queries,
Hmm.
and I love it. It's phenomenal. Like I get to write like flat maps, and those flat maps get turned into like SQL joins and stuff. Like all the SQL stuff I don't want to have to think about and figure out. I just write Scala, and I've really enjoyed using Quill. But of course, for Quill to do this, it uses macros to take that Scala code and turn it into a SQL query. It because we don't want to use reflection, so instead it uses macros to do this. And the libraries of Quill are just genius, like many Scala library authors. But the primary author, Alex, has been working on converting Quill to work with Scala 3 metaprogramming,
Mm-hmm.
and had amazing results at like how much it's simplified what the way that he writes his Quill code that takes Scala code and turns it into SQL queries. So for the tweets I've seen from him, it's pretty positive feedback for like this is a much nicer way to do this metaprogramming.
So for his use case, it's liberating, but we may discover some other use cases where they're going, and I could do this with macros, but I can't do it in metaprogramming. Yep. That'll be interesting to see where are the limitations.
Yeah,
that's what I'm.
Well, and I know that people did their PhDs on exactly that topic, so I'm sure
on where the limitations are.
Yeah, and looking at existing Scala libraries to see, can this be done in the new metaprogramming model? Well, and of course, there were many PhDs that just had to come up with the new metaprogramming model and do it based on what people's needs were, based on how they were using macros. And so EPFL has published a lot of those studies and information and explorations. And I think that they have been working on this particular project for like 5 or 6 years to try to ditch macros and replace it with a metaprogramming. So it's been a pretty lengthy project to be able to come up with this new model for metaprogramming.
I can only imagine. I mean,
geniuses for sure.
Yeah,
and I, they're in uncharted territory with this too. So it's
also, the research, the benefits of the research are, enormous. I think because it could influence other
But yeah,
languages. Very
like maybe Kotlin in a few
Kotlin.
years will take the metaprogramming model that Scala has kind of
Mm-hmm,
done and implement it.
mm-hmm,
Um, I I thought that the Kotlin X serialization library would be macro free because it actually has a compiler plugin that you use. So a
mm-hmm,
compiler plugin is like the annotation compiler, like you can do stuff, to
mm-hmm.
compile with a compile plugin. So I thought that it would be reflection free, but then learned that actually there's still one place where Kotlin does use reflection, or Kotlin X serialization does use reflection, and so that was interesting to see about.
Hmm.
So I wonder at some point, like, will Kotlin be like, we need some metaprogramming capabilities too?
Oh, I'm sure they must have thought about it. I
Yeah,
mean,
I'm sure.
they've definitely taken, and yeah, they're always looking around to see what other languages are doing, and does this make sense to include in Kotlin?
Yeah,
It's very interesting to see how what I consider very thoughtful of a process they go through to before they add a feature. I mean, for example, the result object, and they're balancing that with, well, what kind of impact is this going to make on Java
Yeah,
compatibility, which is super important
yeah, yeah,
because they've done so much to make the Java compatibility really well thought out and seamless.
yeah,
And it's very impressive. But it also gets you a little bit because you're going, they're having to make compromises because of Java.
yeah,
And that anytime I feel the chains, Jacob Marley's chains,
yeah,
dragging you down into the past. You're
yeah.
going, why can't we just?
Yeah, it's interesting how Scala started as a better Java. Like that was the original kind of pitch, was a better Java. And now you don't hear anybody in Scala talking about it being a better Java anymore. It's like, okay, Kotlin can have that title, and now Scala is just like, no, we're we're moving on. We're not
Yeah, and
just a better
I
Java.
appreciate that they aren't like look. I mean, Kotlin is saying, I mean, in my opinion, they're going, yeah, we want to replace Java, and I think that's
Yeah,
great. And Scala is going, no, we're not. We don't care how big our market share is. We're looking at doing amazing pieces of research. We're looking at pushing the boundaries of computer science forward.
yeah,
And if that produces a language that helps you get your job done, great.
yeah,
And I don't know, I really appreciate that
yeah,
mindset.
yeah. That's interesting. I think Martin, he would love to see Scala become the you know de facto general purpose programming language.
Well, of course, but
As a language designer, I guess you kind of have to be in that mindset. But there's definitely some challenges to that. Like, I think for a Java developer or a JavaScript developer or Python developer to move to Scala, it's a bit of a learning curve.
oh
A
yeah.
lot more than like Java to Kotlin.
Oh, I mean, for sure. I feel like when Diana and I started working on Atomic Scala, it was just, I mean, the first year and a half, 2 years, we were just in a fog,
Yeah,
trying to begin to understand what is this about. Because I mean, the mental paradigm shift that you go through,
yeah,
and once you go through it, you go, oh, I see, this really does make sense. But the process of going through that,
yeah,
I think, needs to be a lot smoother. I think that's what we're going to try
yeah,
and achieve with the Atomic Scala 3 book
yeah,
is a much more, keeping in mind people coming from languages where the word functional isn't ever
yeah.
talked about. It's not a
Yeah,
thing.
I remember the moment where I started learning about immutability, and I
Mm-hmm.
was just like, it's not possible to create a program with immutability.
You'd
Like,
run out of memory.
no, I really didn't.
Oh,
There was
right.
that moment where I'm like, no, like I need to mutate things in order to get from point A to point B.
Yes.
Like my brain just could not possibly comprehend a different way that didn't work with
Oh yeah,
without mutation.
totally with you. Yeah, I mean, and I still have trouble sometimes. I mean, like if I'm writing a Python program, I go, yeah, I'm sure I could do this without immutability, but sometimes it's so much easier just to take the thing, change it, and assign it back to the thing.
Yeah.
It's like, it's hard to,
yeah,
it's difficult to get over that hurdle.
there
And especially, I mean, that's the way Python is designed.
Yeah.
It's one of the maxims in the Zen of Python, which, if people don't know, if you start up the Python interpreter and you type import this, you'll get the Zen of Python, which Tim Peters created. And Tim is really
Zen of
thoughtful.
Python is genius.
It is, but one of them is practicality beats purity every time.
Yeah.
And and I've been thinking about that, and that's one of the things that I brought up with the builder and my experiences, and going, yeah, but when I'm trying to get this thing done, sometimes it's mentally easier to just do kind of a builderish thing, and it gets me from point A to point B, and it's not perfect, but it works, and it's not the purity of the result, it's the ability that it gives me to go through these steps while I'm creating the program.
Yeah.
And so I don't know what to do with that.
Yeah, it's interesting. I think that if there is a Zen of Haskell, it probably says that purity beats practicality.
Purity beats everything.
Purity beats everything.
Yeah.
And so
why are you even asking this question?
I think the Scala community, at least the raw functional side of the Scala community, is not that extreme, but that's the mindset that a lot of them are in, is like, yeah, this may not be real practical, but it's pure.
And I totally get that. The feeling that you get when you write an elegant piece of code that has that pure feeling to it it's like when you're leveling up on a video game, which I haven't played video games in a really long time, but I remember the feeling, it actually releases endorphins.
Yeah.
And you go, ooh, this feels good, I want more.
Yeah.
And so I know that happens when you're dealing with functional programming. You're going, oh, this thing that I normally would have done in this sloppy way in this other language, I've done it in this really cool way.
Yeah.
And that feels good.
Yeah.
Look at it. Let's just stare at this piece of code for a while.
Yeah. I mean, an interesting example of this is that if purity is really like one of your core goals, it turns out that random is hard because random is not pure. Like you can't have a pure function that returns anything related to random. Time is the same way. Time
unless you use the same seed for the random number generator, which is how I do it in examples in the book, because you want to test the results, and so I just seed it with the same number.
Yeah. And so to remain pure and have random or time-based things, it adds a complexity that I think a lot of people would look at and be like, yeah, that's not practical. Why can't I just call math.random or whatever?
Well, but you would, to generalize that, it would be time or random or IO.
Yeah.
All of them are kind of IO.
Yeah, we call those effects.
Effects, yes.
It's anytime you touch the outside world.
Right. You get dirty.
Yeah. Yeah.
Yeah, well, it's very much like the difference between pure and applied math.
Yeah.
And it's like, yeah, but ultimately we need applied math.
Yeah.
But there are a lot of benefits that you get from keeping things as pure as possible. You can use mathematical laws and theorems and stuff and know that it works.
That's right.
But you can't deny that at some point you have to interact with the world and get stuff done.
Yeah. Yeah.
And that's
and exactly. There's a tension there. And as you know, I'm very much on the side of purity and keeping my effects isolated, but I've also written a lot of code lately that is not at all in that vein, because for practicality, for reasons that were practical, I had to just choose to give up on my desire for purity to get things done. So
yeah, and I mean, this is the thing that I'm struggling with. It's like, okay, so this works, this code or this technique, process, whatever, it works for some definition of work. I mean, that's the applied math aspect of things. It's like for some definition.
yeah,
Whereas in pure math, it's like, no, it's absolute. The pi r squared is an absolute thing. There's no, and it's like, I don't know. I guess maybe that's what we do. We decide this is okay. This solves my problem. It didn't take very long to do it. If I need to fix it, that'll be fast too. I don't know. And I think when you're dealing with something exploratory in particular, it's like when people talk about test-driven development and they go, well, always write the tests first and then do the thing. And so much of the stuff that I do is exploratory, so I don't even know what the test should be.
Yeah.
And so it doesn't, there's the purity is too pure.
Yeah.
And where do you, I don't know. I guess our jobs as programmers is primarily to say this is good enough, or 10,000 people are going to be using this piece of code, and we've seen what happens with JavaScript. So let's buckle down and get pure on this.
Yeah.
This bad boy.
Yeah. Yeah. It's we have to live in that tension, and I think that, like we've talked about a number of times, that the purity and the happy path are converging. And like I look at what Scala Zio is doing, and it's really making it a whole lot easier for average developers like me to build pure functional programs, and so and stay on that happy path. So I think that this will continue to converge, and I think at some point we won't have to think through the trade-offs so much.
Yeah, I mean, that certainly happened in the evolution. I mean, just during my lifetime in the evolution of programming, it's like, oh, you have to think about this. Oh, we don't have to think about that anymore. We keep ticking things off.
Yeah.
I mean, just memory management used to be huge pain.
Yeah.
And then we got garbage collectors, and then we have Rust, and both Rust and C++ have things that keep track so that you don't lose track of your memory.
Yeah.
And then, I mean, I prefer a garbage collector. I understand the limitations and why you would want to use C++ or Rust in some cases, but most of the time I don't want to think. Yeah. The less I have to think about that kind of stuff, the more in the happy path I am.
Yeah, exactly. Mm-hmm. Yeah. All right. Well,
cool.
Thank you.
Thank you.